educational channel. In last video we discussed about polygon law of vectors. So today we will discuss one important topic, subtraction of vectors. Subtraction of vectors. If any two vectors are given to you, how can you subtract them? If any two vectors are given to you, suppose that p bar and q bar are two vectors, how can you add it? Just add like this, p bar plus q bar, p bar plus q bar. Now we discuss here subtraction of vectors. If two vectors p bar and q bar are given to you, how can you subtract this? So just we keep p bar minus q bar. What does it mean? The vector q bar is subtracted from p bar. What does it mean? The vector q bar is subtracted from p bar. What does it mean? Q bar minus p bar. The vector p bar is subtracted from q bar. These two are same or different? These two are different. These two are different. Here p bar is, q bar is subtracted from p bar. Here p bar is subtracted from q bar. So whatever it may be, what is the subtraction of vectors? P bar, q bar are two vectors. Subtraction of vectors. S bar is p bar minus q bar. P bar minus q bar. So here q bar vector is subtracted from p bar. Next one is S bar is p bar plus minus q bar. This is also called subtraction of vectors. This is also called subtraction of vector. What we have done here, we have add vector p bar to the vector minus q bar. Here we add vector p bar to the vector minus q bar. Minus q bar. Q bar. Both these are same. This is subtraction of vectors. A vector is subtracted from another vector is called subtraction of vectors. So p bar and q bar are q vectors. Subtraction vector is p bar minus q bar. Next one is magnitude of this vector. What is the magnitude of this vector? S bar is, suppose that p bar is a vector like this. Next one is, this is p bar. Q bar is a vector like this. Here the angle between p bar and q bar is theta. Here the angle between p bar and q bar is theta. Next one is the negative vector of q bar is minus q bar. So the negative vector of q bar is minus q bar, that is in this direction. So this total angle is 180 degrees. This total angle is 180 degrees. So this is P bar and this is minus Q bar. Now we are subtracting P bar and this Q bar. Now we are adding P bar to minus Q bar. Now the angle is 180. Angle is 180 minus theta. This is theta and this one is 180 minus theta. This is P bar. So now the magnitude S is root over P square plus Q square plus 2PQ cos 180 minus theta. We discussed this when we are learning parallelogram law of vectors. Resultant vector r bar is equal to P bar plus Q bar. Resultant vector r bar is equal to we discuss this here. When we are discussing parallelogram law of vectors, resultant vector r is root over P square plus Q square plus 2PQ cos theta. Like this, we write here as root over P square plus Q square plus 2PQ cos 180 minus theta. That means root over P square plus Q square minus 2PQ cos theta. Cos 180 minus theta is minus cos theta. So magnitude of negative vector, magnitude of subtraction vector S is root over P square plus Q square minus 2PQ cos theta. If we add two vectors, the resultant vector r and its magnitude is root over P square plus Q square plus 2PQ cos theta. Here we subtract the two vectors and the angle between these two vectors is 180 minus theta. If the angle between these two vectors is theta, the vector P bar is positive and the vector Q bar is positive. But here that is not the case. Here the vector P bar is positive and the vector, this is minus Q bar. So here we are subtracting the vectors. So the magnitude is root over P square plus Q square minus 2PQ cos theta. Only the difference between addition and subtraction of vectors is, in addition of vectors we write it as plus 2PQ cos theta. In subtraction of vectors we write this as minus 2PQ cos theta. So in parallelogram law of vectors we discussed another case, that is that magnitude of P is equal to magnitude of Q. What happens? Magnitude of Q is equal to magnitude of P root over P square plus Q square minus 2PQ cos theta. We discussed earlier This in parallelogram law of vectors. P is equal to Q. So P square plus P square minus 2 P square cos theta, that is equal to 2p square minus 2p square cos theta, that is 2p square 1 minus cos theta. So the value of 1 minus cos theta is 2 sin square theta by 2. So on simplification the value is 2p sin theta by 2. This is the case when the magnitude of these two vectors are equal. And magnitude of these two vectors are equal. So when magnitude of these two vectors are equal, its magnitude is 2p sin theta by 2. Next one is applications of subtraction of vectors. Suppose that here we have taken velocity vectors. So if a particle is moving, its initial velocity is moving. Its initial velocity is v. It's going on with time. Its velocity changes to Vf. Its velocity changes to Vf. So acceleration is A is Vf minus Vi by t. Acceleration is nothing but change in velocity. Acceleration is nothing but change in velocity. So here, that means here Vf and Vi are two vectors. So subtraction of these two vectors with respect to time gives us acceleration. If two velocity vectors are there, one initially velocity vector is Vi, final velocity vector is Vf. They are moving, velocity changes with respect to the time. This gives us the acceleration. Acceleration A is change in velocity by time. So what is the magnitude of this? If these two vectors are making an angle theta, these two vectors are making an angle theta along with each other. So then the magnitude of velocity is Vf square plus Vi square minus 2 Vf Vi cos theta. So when these two vectors are making an angle theta with each other, then the magnitude of this change velocity is delta V means change, V means velocity, delta means change, V means velocity, that means change velocity. So magnitude of change in velocity is root over Vf square plus Vi square minus 2 Vf Vi cos theta. So one condition is there. Suppose that Vf is equal to Vi is equal to, that means magnitude of Vf and magnitude of Vi is same. Vi is same. What happens? Just now we discussed that in subtraction of vectors, two vectors magnitude is change. The value of change in velocity is 2p sin theta by 2. Two vectors మనం సబ్ట్రాక్ట్ చేసినప్పుడు టూ వెక్టర్స్ మ్యాగ్నిట్యూడ్ కనుక సేమ్ అయితే అప్పుడు రిజల్టెంట్ ఆ వెక్టర్స్ని సబ్ట్రాక్ట్ చేసినప్పుడు వచ్చినటువంటి రిజల్టెంట్ వెక్టర్ ఏమవుతుంది? రిజల్టెంట్ వెక్టర్ మ్యాగ్నిట్యూడ్ వచ్చేసి 2p sin theta by 2. Like this, here also Vf and Vi initial velocity is equal to the final velocity. What happens? This is equal to 2V sin theta by 2. Just now మనం క్యాలిక్యులేషన్ ఏంటో చూసాం. 2V sin theta by 2 ఎలా వచ్చింది అనేది జస్ట్ నో మనం క్యాలిక్యులేషన్ అనేది మనము చూసాం అన్నమాట. సో ఇక్కడ మ్యాగ్నిట్యూడ్ ఈక్వల్గా ఉంది. మ్యాగ్నిట్యూడ్ అనేది ఈక్వల్గా ఉంది, వెలాసిటీ కాదనమాట. వాటి యొక్క మ్యాగ్నిట్యూడ్ ఈక్వల్గా ఉందని చెప్తున్నాము. మనం ఈ కేస్ని మనము ఎక్కడ స్టడీ చేస్తాం? ఒక ఆబ్జెక్ట్ వచ్చేసి యూనిఫామ్ సర్క్యులర్ మోషన్లో మూవ్ అవుతుంటే దీని యొక్క స్పీడ్ ఎలా ఉంటుంది? సపోజ్ దట్ స్పీడ్ మనం v అంటే స్పీడ్ v కాన్స్టెంట్, స్పీడ్ v అనేది కాన్స్టెంట్. ఏంటిది? మ్యాగ్నిట్యూడ్. మ్యాగ్నిట్యూడ్ స్పీడ్ అంటే ఏంటి? అది స్కేలార్ క్వాంటిటీలో ఇది మ్యాగ్నిట్యూడ్, మనము స్పీడ్ అని పిలుస్తాం అన్నమాట. నెక్స్ట్ వచ్చేసి ఒక ఆబ్జెక్ట్ v వెలాసిటీ తోటి సర్క్యులర్ పాత్లో మూవ్ అవుతుంటే దాని స్పీడ్ ఎలా ఉంటుంది? స్పీడ్ v ఈజ్ కాన్స్టెంట్. స్పీడ్ v ఈజ్ కాన్స్టెంట్. స్పీడ్ అనేది కాన్స్టెంట్గా ఉంటుంది. మరి ఏవి చేంజ్ అవుతుందయా? వెలాసిటీ చేంజ్ అవుతుంది. మరి వెలాసిటీ అంటే ఏంటి? దాని యొక్క మ్యాగ్నిట్యూడు, డైరెక్షన్ రెండు ఉంటే కనుక వాటి మనము వెలాసిటీ అంటాం. ఒక పార్టికల్ సర్క్యులర్ పాత్లో మూవ్ అవుతూ ఉంటే దాని యొక్క స్పీడ్ ఏంటి? వీనే, ఇక్కడ వీనే, ఇక్కడ వీనే. మరి దాని యొక్క వెలాసిటీ ఏమవుతుందయా అంటే దాని యొక్క వెలాసిటీ వచ్చేసి దాని మ్యాగ్నిట్యూడ్ ప్లస్ డైరెక్షన్ ఈ రెండింటిని రిప్రజెంట్ చేస్తుంది అన్నమాట. సో ఈ పర్టికులర్ ఈ పొజిషన్ దాని యొక్క పొజిషన్ దగ్గర దాని వెలాసిటీ కావాలి. మనం ఏం చేస్తాము? మనము ఒక టాంజెంట్ని గీస్తాము. ఈ టాంజెంట్ డైరెక్షన్ వచ్చేసి మనకి వెలాసిటీ డైరెక్షన్ని రిప్రజెంట్ చేస్తుంది. సో an object is moving in uniform circular motion, velocity is constant or not? No, velocity is not constant. Speed constant. Speed constant. So now the object comes to here. Here also speed is constant, but now the object moves in this direction. So its velocity changes. Its velocity changes. Here the speed is constant and velocity changes. So when Vf is equal to Vi, we subtract these two vectors, then resultant vector, magnitude of resultant vector S is 2V sin theta by 2, 2V sin theta by 2. So ఆబ్జెక్ట్ వెలాసిటీ ఎప్పుడైతే ఉందో దానికి ఏముంటుంది, యాక్సలరేషన్ అనేది ఉంటుంది, యాక్సలరేషన్ అనేది ఉంటుందన్నమాట. So till now we discussed that subtraction of vectors. How can you subtract two vectors? Two vectors are given to you. How can you subtract them? Can subtract like this. So what is the magnitude of this vector? The magnitude of this vector is root over p square plus q square minus 2pq cos theta. When they are making some angle, when these two vectors are making some angle with each other, then the resultant vector magnitude is root over p square plus q square minus 2pq cos theta. Next case is, so if the two vectors magnitude is same, then the case is magnitude of vector is 2p sin theta by 2. Next one is application of subtraction of vectors. The object is moving, its initial velocity is vi, with time its velocity changes to vf. When velocity changes with respect to time, it has acceleration, that is vf minus vi by t. If these two vectors are making some angle with each other, these two velocity vectors are making some angle with each other, then the magnitude of the resultant vector is root over vf square plus vi square minus 2 vf vi cos theta. If the magnitude of these two vectors is same, then magnitude of subtracted vector is, subtraction vector is 2v sin theta by 2, 2v sin theta by 2, delta v is equal to 2v sin theta by 2. So this is about subtraction of vectors and its applications. So your every like is most important for me. Like this channel. If you have any doubts, comment it in comment section. Share this channel to others who is defeating JEE Mains examinations, and subscribe the channel for getting more valuable videos. Thank you.